Let's read this problem. Given an integer array nums that may contain duplicates, return all possible subsets. The solution set must not contain duplicate subsets. Return the solution in any order. What this is saying is that given a list of numbers which might have repeats, find all unique combinations or groups of these numbers, including using none or all of them. To solve this, we are going to utilize backtracking. Backtracking is like navigating a maze. If a path leads to a dead end, you backtrack to the last known decision point and try a different path. There are 5 steps to a backtracking algorithm. Number 1, start. Begin with no numbers chosen. 2, choose. For each number, decide to use it or to skip it. 3, move forward. If you use a number, consider the next one. If you skip it, also move to the next number, but without adding the current one. 4, endpoint. When you've considered all numbers, you made a group. If you see repeated numbers, avoid making the same group again. 5, go back. If one group is made, go back to the last choice and try a different way. This means removing the last number used and thinking about the next choice. Let's use the example of 1, 2, 2. Start with an empty subset. For the first number 1, decide to include it. For the next number 2, decide to include it. For the last number 2, decide to include it. Now backtrack. Remove the last number and decide to exclude it, but there are no more numbers to consider, so backtrack again. Now you're looking at the second number 2. Remove it and decide to exclude it. Then consider the last number 2 and include it. Repeat this process until all paths or subsets are explored. Let's do the code. We begin by initializing an empty list result that will store the subsets we generate. We sort the input list nums. Sorting helps in handling duplicates because duplicate values will be next to each other, making them easy to identify and skip when needed. We define a nested helper function, backtrack, which will do all the actual work of generating subsets. It takes 2 arguments. Start, the index in nums from where we should begin considering elements. Current, the current subset we're building. Inside the backtrack function, we add a copy of the current subset to the result. This ensures every subset, including the empty ones, get captured. Iterate through nums. Starting from the start index, we iterate through each number in nums. There are 3 points of emphasis. Skip duplicates. If the current number is the same as the previous one, we skip it. This avoids generating duplicate subsets. Include the current number. We add the current number to the current subset and then call the backtrack function recursively, moving to the next index. This simulates choosing the current number. Exclude the current number. We remove the last added number from the current subset. This simulates not choosing the current number and is the actual backtracking step. We initiate the backtracking process starting from index 0 with an empty subset. And finally, we return.